NASA just revealed something that shocked the industry. A December 11th filing showed they're awarding SpaceX a sole source contract for Starship, Starlink's classified military network that almost nobody talks about. 7 terminals across 3 continents, 8 encrypted government-only data channels, each handling 5 terabytes monthly. Why does NASA suddenly need SpaceX's most secretive satellite system? Here's the real surprise. They're integrating it into the deep space network. What mission requires this level of classified encryption? Let's talk about what Starship actually is, because this isn't your typical Starlink network. While Starlink beams internet to millions of consumers worldwide, Starship operates in complete silence. SpaceX doesn't announce launches. They don't publish satellite counts. They don't even confirm which missions carry Starship payloads. What we do know is this. Starship was built specifically for the U.S. government and national security customers, offering communications, Earth observation, and classified services that regular Starlink simply cannot provide. The encryption standards alone tell you everything. Starlink already uses end-to-end encryption for all user data. Starship takes it several levels higher with what SpaceX calls higher assurance cryptography, the kind designed to handle classified payloads and meet the strictest government security requirements. NASA's procurement filing specifically demands AES-128 encryption or better, plus additional protections for sensitive and export-controlled data. This is military-grade infrastructure operating in orbit. Now, here's where NASA comes into the picture, and why this partnership matters more than it might seem at first glance. The Deep Space Network is essentially NASA's lifeline to everything exploring beyond Earth orbit. 3 massive antenna complexes, one in Goldstone, California, one near Madrid, Spain, and one near Canberra, Australia, strategically positioned around the globe so at least one site can always maintain contact with distant spacecraft as Earth rotates. These antennas communicate with Voyager probes at the edge of our solar system, rovers on Mars, missions to Jupiter's moons, and soon, astronauts returning to the lunar surface under Artemis. But the DSN is under serious strain. Demand keeps growing as more missions launch, but the infrastructure hasn't kept pace. Earlier this year, one of the massive 70-meter antennas in California went down due to damage, exposing just how vulnerable the entire network can be. When a single antenna fails, mission operators scramble to reschedule communications across remaining sites. Critical data gets delayed, science observations get missed. For crewed missions, that kind of disruption isn't just inconvenient. It could be dangerous. The current system relies almost entirely on terrestrial fiber optic connections to link the 3 DSN sites together. If those ground lines get cut or compromised, the network's redundancy disappears. That's the problem NASA is trying to solve with Starship. Instead of depending solely on cables running across continents and ocean floors, they want a space-based backup that can keep all 3 sites connected, no matter what happens on the ground. 7 Starship terminals across the 3 locations, 8 data subscriptions, each capable of moving 5 terabytes monthly through government-only encrypted channels. A 6-month pilot program to prove the concept works. Think about what NASA is really saying here. They're willing to integrate a commercial satellite network, albeit a highly classified one, into the most critical communications infrastructure they operate. The Deep Space Network isn't just important, it's irreplaceable. There's no alternative system that can reach spacecraft billions of miles away. NASA has run this network for over 60 years, and now they're trusting SpaceX to become part of its backbone. That's not a decision made lightly. What makes this even more significant is the timing. SpaceX just wrapped up an absolutely monster year. Gwynne Shotwell, SpaceX's president and COO, recently confirmed they hit their revised target of 165 Falcon 9 launches in 2025, with 2 more flights still scheduled before year's end. That's 167 total launches, shattering their previous record of 134 set just last year. To put that in perspective, 5 years ago, in 2020, SpaceX flew about 25 missions total. Now they're launching every 2 to 3 days on average. The company has a second stage rolling off the production line every 2.5 days. That kind of operational tempo doesn't happen by accident. It requires absolute reliability, precision manufacturing, and a level of organizational execution that most aerospace companies can't even approach. Shotwell herself has been the driving force behind much of this success. While Elon Musk paints the ambitious vision, Shotwell runs the day-to-day operations, manages customer relationships, and delivers on the promises. Forbes just recognized her as the 20th most powerful woman in the world for 2025, ranking her just ahead of Taylor Swift. That's not marketing hype. That's acknowledgement of someone who keeps systems running that governments literally depend on for national security and global connectivity. And then there's Starship, the program that could genuinely reshape spaceflight if it delivers on its promises. SpaceX flew Starship 5 times in 2025 as part of the Integrated Flight Test campaign, all using Block 2 hardware. The year had serious growing pains, 3 consecutive upper stage failures in the first half that raised real questions about the design's maturity. Flight 7 in January saw the booster caught successfully, but lost the ship during ascent. Flight 8 in March repeated that pattern. Flight 9 in May marked the first booster reflight, but the upper stage failed during its coast phase. The second half of the year told a different story. After a ground explosion involving Ship 36 delayed progress through June, Flight 10 in August marked the turning point. The upper stage completed its trajectory, deployed mock Starlink satellites, relit engines in space, survived re-entry with heat shield testing, and executed a controlled splashdown in the Indian Ocean. Flight 11 in October built on that success, testing advanced re-entry maneuvers while flying with missing heat shield tiles intentionally to push the limits. By year's end, SpaceX had demonstrated booster reuse and repeated tower catches, setting the stage for the Block 3 transition. SpaceX originally hoped for 25 Starship flights in 2025. They managed 5. But here's what matters. They learned. Every failure taught them something about the Block 2 design. Every success proved out capabilities needed for operational missions. Now they're transitioning entirely to Block 3 hardware, with no more flights planned until that upgrade is complete. This is the SpaceX that NASA is betting on with Starship, a company that can launch 167 times in a year with Falcon 9, a company pushing the boundaries of what's possible with Starship despite setbacks, a company run by Gwynne Shotwell, who's proven she can deliver on operational excellence at unprecedented scale. NASA isn't just buying satellite terminals. They're buying into SpaceX's entire approach to space infrastructure, rapid iteration, high reliability, and systems that work when everything else fails. But there's another layer here worth examining. NASA has been working with SpaceX and other companies on a separate effort to support communications for spacecraft in Earth orbit using commercial systems. In that program, SpaceX is demonstrating an optical relay network using regular Starlink satellites, not Starship. So why use Starship specifically for the DSN pilot program? The answer comes down to security requirements and mission criticality. Communications with deep space missions carry data that can't afford to be compromised. Scientific observations worth billions of dollars. Telemetry from systems operating hundreds of millions of miles from Earth. Commands that control spacecraft where a single mistake could end missions that took decades to plan. That demands the highest level of encryption and data protection available, exactly what Starshield was designed to provide. NASA hasn't previously discussed using Starshield for DSN operations at all. This procurement filing came out of nowhere. That suggests this pilot program represents a significant strategic shift in how NASA thinks about resilience and redundancy for deep space communications. If the 6-month test succeeds, we could be looking at the first step toward weaving SpaceX's most secure satellite network directly into the backbone of how humanity stays connected to its farthest-reaching spacecraft. The implications stretch far beyond just NASA. If Starshield proves it can reliably support the deep space network, what else becomes possible? Military communications that can't be jammed or intercepted, emergency backup systems for national security satellites, a completely space-based command and control network that doesn't depend on vulnerable ground infrastructure. SpaceX isn't just launching satellites anymore. They're building the architecture that governments will rely on for critical operations in orbit and beyond. So what's the real story here? NASA just handed SpaceX the keys to one of the most critical communication systems humanity operates. The Deep Space Network has been NASA's exclusive domain for 6 decades, and now they're integrating a commercial satellite network, even a classified one, into its core infrastructure. That decision says everything about where SpaceX stands in 2025. This wasn't inevitable. SpaceX earned this trust by launching 167 times in a single year with near-perfect reliability. By pushing Starship through failures until they cracked the code on booster reuse and controlled re-entries. By building systems that governments depend on when everything else fails. Gwynne Shotwell and her team proved they can deliver operational excellence at a scale nobody thought possible a decade ago. The 6-month Starshield pilot is just the beginning. If it succeeds, we're watching the foundation being laid for a completely new approach to space communications, one that doesn't depend on vulnerable ground cables, one that can't be easily disrupted, one that scales as humanity pushes deeper into the solar system. When Artemis astronauts are working on the lunar surface, when the first crewed missions head to Mars, when we establish permanent infrastructure beyond Earth orbit, this is the kind of backbone they'll need. SpaceX isn't just launching rockets anymore. They're building the invisible infrastructure that makes everything else possible, and NASA just confirmed they're ready to bet the future of deep space exploration on it. What do you think? Is Starshield the future of deep space communications, or is NASA taking too big a risk with critical infrastructure? Drop your thoughts in the comments below. If you found this breakdown valuable, hit that like button and subscribe to New Space Review for more in-depth analysis of what's really happening in the space industry. We're just getting started.